Okay, so our first objective for 1.2, we want to make sure you guys understand the difference between acute, right, obtuse, and straight angles. So acute angles are acute little tiny angles. So they are angles whose measure is between 0 and 90 degrees, okay? A measure whose angle is between 0 and 90 degrees. Right angles are angles whose measure are exactly 90 degrees, and we denote that with this little box in the corner that you guys are going to start to see. Obtuse angles are angles whose measure is in between 90 and 180 degrees. So it could be 91 degrees, could be 179 degrees. And our last ones, straight angles, are literally that. Those are angles whose measure is 180 degrees, okay? So you're probably asking yourself, how is that different than a line? An angle is a movement, okay? A line is just a straight line. An angle is something like your windshield wiper, where it goes back and forth at 180 degrees. So again, an angle is a movement. I put these little inequalities down here for you guys. So I would copy those. Again, an acute angle whose measure is between 0 and 90 degrees. Okay, that's in pink right here. A right angle whose measure is exactly 90. An obtuse angle measures between 90 and 180, and a straight angle whose measure is exactly 180 degrees. So the next order of business is to talk about the word congruent. So congruent means of equal measure. So in geometry, congruent is just like equal in algebra. So it means that if I took this angle and actually slid it on top of this angle, that their measures would be exactly the same. So over here I denoted in pink. So these are segments. And I told you that segment AB is congruent, and here's my symbol, highlight it in pink, is congruent to segment CD, okay? We say the measure of AB, for example, it could be 5 centimeters, is equal to the measure of CD. So congruent is actually referring to the segments, okay? And then we also have these angles. The measure of angle ABC is congruent, this is my congruent symbol, to the measure of angle DEF. So if these measures were congruent, right, so maybe we'd see some tick marks in here, you might see some actual degree marks in there. We denote this with this congruent symbol. So the measure of ABC is congruent to DEF. And then our last kind of goal for section 1.2 is to talk about degrees, minutes, and seconds. I'll erase those. And so degrees, there we go, move it. Degrees uses this symbol, what you guys are used to, it's that little bubble. For example, 70 degrees, okay? And that's talking about an angle. But when we get really specific about an angle, we can also have 70 degrees, and we can have minutes on there, 30 minutes. And we'll start talking about what 30 minutes represents. And then we also have seconds. So we can actually have, let's say, 30 seconds. So down here, I want to talk to you guys about what a minute means. So let's talk about what a minute means, and then we'll do some actual work. So a minute, or for example, 1 minute, is equal to 60 seconds, just like it would normally, okay? Just like a degree, 1 degree is equal to 60 minutes. So if I come up here and look at this, 30 minutes is equal to a half of a degree. 30 minutes is half of a degree, just like 30 minutes is half of an hour. Okay, you can think of this like hours, minutes, and seconds. That's almost exactly what it is, but it's degrees, minutes, seconds, but same exact principle. And then seconds, of course, there are 60 seconds in a minute. Okay, right here. 60 seconds, I should circle this. Seconds. 60 seconds are 1 minute. 60 minutes is 1 degree. Okay, just like we normally would. 60 seconds is 1 minute. 60 minutes is 1 degree. Okay, 60 seconds is 1 minute. 60 minutes is 1 degree. 60 seconds is 1 minute. 60 minutes is 1 hour. Same thing. Okay, so when we come over here and we look at this 180 degrees, I can also say that 180 degrees is the same thing as 179 degrees and 60 minutes, because 60 minutes is 1 degree. I can also say that it's the same as 179 degrees, 59 minutes, and 60 seconds. So these 3 degree measurements are interchangeable. They all are equivalent to each other. They all mean exactly the same thing. Okay, so going back and forth. So sometimes I'm going to have you guys change degrees into minutes and seconds. So if we take a look at my example number 1 right here, I have 132 3/16 of a degree. So what I can do is I can change this to 132 degrees, and I want 3/16 of 1 degree, or of 60 minutes. Okay, and then we're going to go ahead and we're going to do that math. So I want 3/16 of, or times, a degree. And if you look up here, 1 degree is 60 minutes. Okay, so this turns into 132 degrees, and then you can do your math. So if you guys have your calculator, you can multiply 3 times 60 and then divide it by that 16. Or you guys can just go ahead and cancel these. We have 8 and 30. I'm going to cancel it again, 4 and 15. And so what this turns into is 45 fourths. Or if you guys just multiplied it and you divided it, you probably got 11 and 1/4 of a minute. Okay, and again, I'm assuming you guys are using a calculator, so make sure you can use your calculator and multiply 3/16 times 60, and you should come up with 11 and 1/4 minute. Now, I don't like the 1/4 of a minute, and some of you guys might know, oh, it's 1/4 of a minute, so I know that's 15 seconds. If you don't, this is what's actually happening. We have 132 degrees. We have 11 full minutes, and we have 1/4 of a minute. So 1/4 of a minute, which is 60 seconds. And then again, you would multiply 1/4 times 60, and your final answer is 132 degrees, 11 minutes, and 15 seconds. Okay? When you are converting from degrees to minutes and seconds, all you do is multiply by 60. So to go from degrees to minutes and seconds, you multiply by 60. To go from minutes and seconds to degrees, you actually divide by 60. Okay? And then the last thing we're going to talk about is something called a clock problem. So what angle does 5 o'clock make? So I kind of made my clock over here. So if we're actually talking about the angles on a clock, okay, if you guys take a look at this, we can split this up into slices. And each of these slices, not by my drawing, but on a normal clock, are going to be of equal measure. So if you take a look at this, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And because there are 12 equal slices and a full circle is 360 degrees, if I take that 360 and divide it by the 12 slices, each slice represents 30 degrees. So if I ask you what the measure of 5 o'clock is, all I'm doing is I'm adding 35 times. So I'm just looking at this angle right here, and we can see that this measure would then be 150 degrees. And of course, not every problem is going to be that easy. So I'm also going to ask you guys, what angle does 545 make? So if I come over here, again, the minute hand is right on the 9. Okay, so right here, this pink slice represents 30 degrees. This blue slice represents 30 degrees. This orange slice represents 30 degrees, but then I have this little sliver here. Okay, and so what we have to do is we have to figure out what portion of the 30 degrees is this. Okay, so what happens is, in this time period, if I'm looking at this green piece, my clock hand moved 45 of the 60 minutes. It moved that much. So how much does my clock hand have to move to get to the 6 o'clock mark? It has to move 15 of the 60 minutes. Okay, again, my clock hand moved from 5 to that point, to this point right here, 45 of the 60 minutes, which means it has to move 15 of the 60 minutes still. So 15 divided by 60, that's the fraction of the 30 degrees. And so what that ends up being when you multiply it is 7.5 degrees. So if I asked you guys to add those up, you would tell me 30 of the pink plus 30 of the blue plus 30 of the orange plus 7.5 degrees in the green. So a total of 97.5 degrees that clock hand has moved. The clock hand is measured, I should say.